Hello everyone. In this video, I will show you how to define events using random variables. So let's assume that we have a random variable. Let x be a random variable. So since we have started studying a discrete one, so here I'm assuming it is discrete, but in general, this is true for all random variables. Defined on sample space S. In other words, for any sample point from S, it gives and assigns a number. Then we can use X to define events. X can be used to define events. The events that we can define using random variables are defined using equalities and inequalities. For example, x equal to a number. This is an event, so is the event consists of all sample points at which x is equal to a. In other words, you go find all the points that when we plug in at x, or the value of the random variable x for those sample points is equal to a. Gather all those ones, put it in a subset of S. That is the event given by x equal to a. Well, we can have something like x less than a, less than equal to a. Well, this means that the event consists of all sample points at which x is less than or equal to a. Well, similarly, we can do x less than a. Well, this will give us all the points that at which x is less than a. Put all those together, and that will give you the event x less than a. And similarly, one can define things like the other way around. So take like x bigger than a, or x bigger than equal to a, or the inequalities from both sides, something like this. So all these guys define events, and we, in all the cases, we pick the sample points at which the value of the random variable satisfies the given inequality or equality. Okay, let's see these guys in some examples, and you'll see what I mean here. Consider the random variable that counts the number of hits in an experiment where a coin is tossed 3 times. We worked with this random variable before. Remember that in that case, our sample space, so we toss a coin 3 times. So first time it can get tail, 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 then head, tail, tail, THT, TTH, or HHT, head, tail, head, and tail, head, head, or the for example, all 3 can be head. So the random variable x, what it does is that to any of these these points, it gives the number of h in that one. So for example, here it gives 0, this is 1, this is 1, this is 1, this is 2, 2, 2, and this is 3. Okay, now let's see what are the questions that are asking. It says that find the following events. X equals to 1. What is this event here? So if I put it in bracket, let me say that, okay, so this is an event. This is an event for which X will get number 1. So X gets 1 here, 1 here, 1 here. So all the points for which X is 1. So 1 point, 2 point, 3 point. Put all of them together. That forms a subset of S, which we call an event, yes? So instead of writing that, we can use that convention there, X being equal to 1. Or this part 2 says, what is X equal to 10? So we toss a coin. What is the for what cases we can get 10 heads? We are tossing only 3 times, so we cannot get 10 heads. But what does it mean in terms of the event? You see, there is no element or there is no sample point for which X is equal to 10. In other words, here the event is the empty set. Part 3 says find all the things for which X is less than 2. So here, so let's see. X is less than 2, does not include 2, but anything less than that. Well, here I have all these guys up to 0. X is either 0 or 1 if X is strictly less than 2. So in this case, we get T, 3 tails, 1 head, 2 tails in different orders. Okay. And the fourth part is X bigger than 0, less than equal to 2. So here we are taking into the account all the cases which are strictly bigger than 0 and less than or equal to 2. So that would be all these sample points. I'll put all of them together. And that would give me the event defined using X and that inequality. Okay. Well, later you will see that we may ask probability of that event, X being equal to 1. So here in this case, there are 3 out of 8 that will give you the number. Or what is the probability of X being less than 2? Here, there are 1, 2, 3, 4 out of 8, and that's 4/8, and so on. Okay, let's do one more example. Let Z be a random variable that counts the number of balls that John draws from the bag, which contains 3 black balls and 2 white balls, one by one until he gets a white ball. So in that case, our sample space is going to be, well, in the first draw, he gets white ball. That's it, done. In the first draw, he gets black ball, so he tries another one and then gets white and stops there. Or the first one black, the second one black, then the third one white and stops there. The first one black, second one black, third one black, and then white. Well, remember that there are only 3 black balls, so this cannot continue further. So this is the whole sample space. Now, Z is the random variable which assigns these guys the number of balls drawn by John. So here there's only 1 drawn, here 2, here 3. Note that we are counting both black ones and white ones because those are, and this is 4. Now, probability of, the event z equal to 3 means put all the points, sample points for which z is equal to 3. There's only one, b, b, w. How about z being greater than equal to 2? So here you see this is 2. We must include that anything bigger than that. So this must be bw, bbw, and b, and white. Yeah. How about z less than 4 complement? Here, z less than 4 means that strictly less than. This is important. We are not including 4. There is no equality there, yes? So anything less than that, this will give us w, bw, bbw. Now, there is a complement here. So complement of that, this is our universal set. So complement of that will have only one entry, which is this guy. And this is the same thing as the event z being bigger than equal to 4. The complement will work the same way as inequality flipped. Okay? So these are how we define events using a random variable.